All right. Looks like I think we can get started here. So welcome to everybody's here. This is our, I think, second webinar that we've done for off-highway markets. My name is Blake Harris. I'm product manager for off-highway. But this is engine cooling systems for mining. So we've got a few experts here to talk about it. But first of all, I want everyone to know if you have any questions for these guys. Feel free to pose them in the chat and we'll try to get to them throughout the presentation. If not, we'll have a Q&A at the end where we can talk about it as well. This webinar is also being recorded, so and will be emailed out to those registered after we have concluded. So like I said, I'm Blake Harris. I'm product manager for off-highway for Horton. I have been with Horton for about a little over 4 years. I've worked in application engineering, always in off-highway, as well as now product management as well. We'll start off. These are our three panelists, as you can see. So number one will be Neil. He's our lead sales engineer for off-highway, focused in construction and mining. Neil, maybe introduce yourself.
Yes, hello everyone. Thank you for joining our webinar today. I'm Neil Schwalik, lead sales engineer. As Blake mentioned, I work in construction and mining markets. I've been with Horton for 24 years. I have a mechanical engineering degree, so I understand the technology and basically work with OEMs in this market space.
Perfect. Next would be Ricky coming from us from Australia. So he's our sales manager for Asia Pacific, working with both mines and OEMs. So Ricky, welcome.
Yes, hello everyone. My name is Ricky Terrell. I'm the sales manager for the Asia Pacific region. I've been with Horton for the last couple of years, but prior to that, I was with a Horton distributor for 15 years. So I've been looking after the Horton product in Australia for 17 years, predominantly in the mining and off-highway space, but also in the on-highway. But yes, welcome.
Excellent. Thanks for joining us. Next would be Matthias. So Matthias is our sales director for off-highway markets in Europe. Welcome, Matthias.
Thanks, Blake. My name is Matthias Seufert. I'm with Horton since 5 years, and myself and my team, further 2 team members, are managing the European off-highway business.
Excellent. So just a brief agenda before we get started. So first of all, I'm going to give a brief, less than 5-minute overview of kind of Horton, who we are, and what we do. But we're going to focus mostly on cooling fans and fan drives. So the 2 main areas of expertise for Horton as it relates to mining. And we're really going to focus on kind of 3 main areas of the technology with regard to durability, efficiency, and productivity, as well as noise. So just like I said, a brief overview of Horton. We are headquartered in Minneapolis, Minnesota. We are, as you can kind of see from our panelists, we are global. So we have over 900 distribution locations. And really we focus on the customer. So we have 4 technical centers located globally. Like I said, the distribution locations, but really what we specialize in is, as a supplier, is getting our resources out to customers. So we have a global network of test engineers. We have application engineering, sales, obviously, design, all very customer focused. And kind of just obviously this is a smaller engine than what you'd see on something in a mining application, but kind of a good overview of the products that we do provide to our markets. Mostly front engine accessory drive type applications. So you have the fan drive, the associated controls, so closed loop controls, as well as our own controller line of controllers, as well as front engine accessories from tensioners to pulleys, and then as well as drive hubs and tensioners. Mentioned the global footprint, so kind of showing the main core mining areas that we're focused in. Focused on reliability and durability. You can see a brief list of some of our construction and mining customers, focused on productivity, efficiency, as well as noise, as I have mentioned. So, like I said, very brief intro of Horton, but we want to get a little bit away from Horton and more focused on the actual technology here. So this will be more of a discussion among panelists. We want to really provide the customer view from OEM perspective and the the mine perspective through the lens of our guys that are working with these folks every single day. So first of all, just a brief overview. We have metal fans with plastic, nylon, H-Tech. These are the kind of not just what Horton provides, but these are the types of fans that you'll see in mining applications. So first of all, I just want to kick it over to Neil. Neil, can you tell us from an OEM perspective some of the experience you've had with these various types of fans, kind of where they're used and why, maybe touching on most of the points here that we have below each technology?
Yeah, sure. So really the metal fans have been really the de facto standard in the mining industry for many, many years. And the reason, I guess, being that it's really been the only thing available, number one, but number two, they've worked well. And it's been available for many, many years. And what we're finding is that customers, OEMs and end users are really looking for advanced technologies, additional features that the metal fans can't provide. And so what we've done is we've really tried to address those issues and challenges by designing a new fan. So when you look at the technologies, though, again, metal being of primary use, you also have plastic or nylon modular fans. So these are going to be types with steel centers and plastic blades, or you might have plastic blades that are over molded onto a steel type of a center disc. And then lastly, you get into the H-Tech fan, which is the Horton offering, which is a thermoset composite blade that is huck bolted onto a steel center disc. So when you look at all of the different features and benefits, what we've shown on the slide here is the metal fan kind of being baseline or neutral, across the board on all different areas, simply because that's what's in primary use today. And when you look at plastic or nylon and H-Tech, you can see advantages and disadvantages of both those technologies. I guess just going down the list here, talking about airflow and efficiency, there's challenges with metal fans to optimize blade design because you're limited on the blade types and styles that you can really do with the metal fan. So when you get into plastic, nylon, or H-Tech technologies, you have more available options to customize the blade designs and really optimize efficiency. Just as an example, I'm thinking of a cooling test that we ran with an OEM where, compared with the metal fan versus the H-Tech, kind of in an A to B scenario, the H-Tech provided, I think it was 5 degrees C better LAT in that particular package, just A to B, and that's purely from the fan efficiency standpoint, airflow per unit power. So there are, again, advantages moving into some of these other technologies. From a noise perspective, we've also seen some of the same results with the noise and lower dBA levels from the fan. Again, and that's also primarily because of the blade efficiency and the blade designs that you can get with, again, either plastic, nylon, or H-Tech fan.
Quick question there. So you mentioned a little bit, obviously we're talking about airflow, efficiency, noise, and how that relates to kind of the blade design. Mm-hmm. What can you tell us about kind of how those blades are made, each one of those technologies?
As far as like the manufacturing and construction?
Right.
Or?
Okay. Yeah, just at a high level.
Yeah, well, typically metal fans, you're going to have the blades are going to be, stamped and rolled using, manufacturing cells, and so you're really limited in the kind of geometry that you can get out of the metal fan. Whereas plastic and H-Tech, you're going to be looking at either a molded blade, whether it's injection molded, or it could be a compression mold type of a situation or type of a process. But that gives you much more flexibility because you can design the fan blades to have variable chord angles, swept blades, etc. Just things you can add into the design to increase the efficiency and improve.
How does that affect noise? With maybe like the tips of the blades, and like you were talking about different chord angles and things.
Yeah, basically, well, the the metal fans are really limited with the type of design you can have. And so when you get into plastic or H-Tech fans, you can design the blades with curvatures that will help with the noise aspects, just with the way that the fan produces the air and with the way that the air leaves the fan blade.
Right.
Yep.
Exactly.
Yep. And so, and again, that's one of the things that we've looked at, looking into the future and looking at what the customers are asking for, both at the OEM side and the mine sites too, for noise reduction. So that is something that we've incorporated into our designs, and we've seen evidence of reduced noise levels, reduced sound emissions from the mine trucks using our technologies.
Thank you.
So then moving on into like the durability and weight aspect. Durability, plastic and H-Tech fans have an increased durability simply because there are reduced number of joints, basically. The issue with nylon that we've seen in the marketplace is that the material just is not durable enough for that type of an aggressive environment. And so we have had customer experiences with nylon fans where they've failed and they just had durability issues. H-Tech fan, it's a thermoset composite material. It's a completely different. It has completely different material properties than a nylon fan. It looks plastic, but it's not. And so we've had great customer experiences with the H-Tech fan on the durability side. And then from a weight aspect, metal fans are heavy. You're going to have steel blades, steel center discs. Some of these fans can weigh, I think 300 plus pounds for a 96-inch fan. And so when you get into the plastic or the H-Tech fans, there are weight advantages to go into those technologies. And that's important for both the OEMs, really for the OEMs, because they can have it opens up design aspects for them on the trucks, and then there's also moment load considerations for the the front end of the engine with whether it's a drive hub or a clutch or a hydraulic motor, whatever you're putting the fan on. Less weight equals less moment load, which increases bearing life. So there are advantages to going to a lighter weight fan.
Perfect. Thanks, Neil. So let's go to Matthias in Germany. So less mining OEMs kind of in Europe, we would say, but lots of construction customers that you work with on a daily basis that are speccing both nylon fans as well as metal. What can you tell us about kind of the decision points between metal and plastic nylon, and why your customers might go one way or another?
Yeah, I mean, European customers are typically looking more and more into noise and fan efficiency. There are certain markets that still require metal fans like dosers, but other than that, the customers are pretty flexible to the materials. And as Neil mentioned, one of the first H-Tech projects we had in Europe a couple of years ago, that was on a 100-ton dump truck. And the customer was pretty far down the road with pre-series testing when they ultimately found out that they had a weight issue with the existing metal fan, and that they did not get the final acceptance from the engine manufacturer. So we were approached and we spec'd in an H-Tech fan that matched the performance of the metal fan but had much less weight, and this ultimately solved the problem. And the funny thing is, as Neil mentioned, the H-Tech looks a little bit like plastic. The customer told me when they first got the first H-Tech fans and they opened the box, they initially thought that is a plastic fan. So they put the fan on the floor, stepped on the blades to see if they crack, and they did not. So they put that on the truck, and that is now the series fan into that platform and also in another platform at that customer. And we also see mining customers that the customers are looking more and more into alternative solutions. As Neil mentioned, metal fans were there forever, but we see more and more customers really looking into alternative fans and also alternative fan drives for efficiency reasons. We have another project customer just finished testing with a viscous fan drive and a modular fan, and the feedback was it's more effective than the technology they're using today. It's less weight and it's less expensive for them, so they will switch over in series production to a new technology.
Very good. Thanks, Matthias. So let's get Ricky involved here a little bit. So like I said earlier, you have a very unique perspective because you're working with the Asia Pacific OEMs as well as the mines in Australia, where you've been working for for well over a decade. So Ricky, what can you kind of tell us about these design trade-offs and what you see in Australia?
Yeah, sure. Thanks, Blake. Look, there's been a couple of main factors that have driven change here in Australia, from going from the metal fan through to the H-stick fan. But the main factor that has really driven that change is durability and performance. Now, we have some areas in Australia, believe it or not, that are sound sensitive. Mine sites that are close to townships that have to keep noise to a certain level, and one of these areas is known as the Hunter Valley region, and they have gone ahead and used a lot of H-stick fans in that area to really potentially initially was to bring the noise down, but that has proven to be a benefit to them by being able to replicate the same airflow but slow the fan down considerably. And by doing that, they've been able to obviously reduce the noise of airflow coming through that cooling package. But the other aspect is durability. The H-stick fan's been in Australia now since 2015, and it's proven itself in a lot of these truck platforms. When we first started swapping out the H-stick fan for the metal fans were getting roughly around 15 to 24,000 hours, and that was being changed in regular repower program intervals. So a lot of the durability problems that they were seeing with the metal fan was eliminated when we switched to the H-stick fan, and now we're actually getting up to around the 36,000 hours. And changing out the H-stick fan at 36,000 hours at life of engine is a good result, especially for the mine operator.
Absolutely. So with regard to those failures that you were talking about with the metal fan, or at least just not necessarily even failures, but just the length of life, like what are you seeing for kind of failure modes? Are they just simply wearing out? Is it an application issue? Yeah, tell us a little more about that.
Sure. So a lot of the failure modes that we're seeing was fretting, and when the metal fan would fail, it'd catastrophically fail. So it'd take out the radiator cores. So if an operator can get life of engine and not have to worry about or put too much concern into whether or not the fan will fail prematurely, then that's a huge benefit, especially if they've got over 100 trucks running around on their site. So just one less thing they have to be concerned about when they go through the servicing aspects.
Right, but, so that durability piece quickly turns into other issues, right? So that durability turns into a safety issue specifically. Potentially, it could turn into. Go ahead.
Well, it's downtime, Blake.
Downtime.
So,
exactly.
It's 100% downtime. So if the truck's off the road, not moving material, then that's costing the operator money. So if they can reduce the downtime, then it's a benefit. It's a massive benefit.
Absolutely. And you mentioned the efficiency piece and how if you have a more efficient fan, that can create positives throughout the rest of the vehicle. Meaning if you have a semi-variable or a variable fan drive and you have your blade is producing more airflow for that revolution, for that rate I should say, then you can slow the fan down and you can have reduced noise. You could have just makes the whole truck more efficient.
100%. I mean, this is just with the fan. This is not even going into the fan drive. So if you can replicate the same airflow as what the metal fan's doing and slowing the fan down by pulling the same amount of airflow, it's a benefit to that cooling system on the track.
Perfect. So that's a good segue kind of into the mining fan drive discussion. a bunch of different types of technology that potentially could be used this application. Obviously, durability is number one. So it kind of brings us to, centered on three main ways to drive your fan. So, as with the last discussion, let's go right to Neil from the OEM perspective. Tell us a little bit about these various types of fan drives, where they're used, both for like the 100-ton trucks, we'd say, and then also the ultra class.
Yeah, sure. Yeah, thanks, Blake. So, yeah, there's really just a handful of technologies that are available out there for fan drives for the mine trucks. So you've got your kind of your baseline direct drive, which is just engine mounted fan drive, runs the fan 100% of the time, and then moving into what we call the semi-variable drive, which is sort of the I guess the standard offering today. If somebody wanted to put a variable speed fan drive on an engine, this would be what's available today. And then the fully variable closed loop fan drive, which is the Horton RCV 2000. There's also another technology. These are engine mounted. There's also another technology with a hydraulic fan drive, which isn't shown here because we're focusing on engine mounted drives, but that is also another option for a variable speed fan drive. So, what we've seen really in the market is that the direct drives have been in use obviously for many years, but with everyone wanting increased efficiency, reduced fuel costs, more horsepower to the wheel motors, increased road speed, there's been really a move over the last 5-10 years into more variable speed technology. And so a lot of the trucks today will have, in the mining industry, will have the semi-variable drive offered as sort of the standard. And there may be options for a direct drive for a customer that maybe doesn't want to pay the premium or the upcharge with the semi-variable drive. But really, when you're looking at 70 to 100 ton trucks, a lot of those are going to be either direct drive or the semi-variable drive. And then as you get into the ultra class, more and more of those have gone to the semi-variable drive as the standard fan drive offering, simply because when you're getting into fans that are 72, 84, 96 inches, I mean these things can pull 100 horsepower. So it really makes a lot of sense to go to some kind of a technology other than the direct drive. And then finally, with the fully variable drive, which is Horton's RCV 2000, this is kind of the I guess what we consider a little bit of a game changer in the market, because it does combine sort of the positive aspects of both the hydraulic and the semi-variable drive into one package. This is basically it's in test at a number of different OEMs. It's available, or it was shown on the D98 engine at Bauma, and it's also now standard on the Komatsu 830E-5 and 930E-5 trucks. And we are going to see more and more adoption of this technology into the mining market.
Very good. So you mentioned kind of the high-level overview of the technology. We're going to get a little bit more into that and the pros and cons associated with them. But first, I wanted to go to Matthias. So Matthias, viscous drives or fully variable fan drives have been prevalent in the European markets for decades, and your guys have a lot of experience working with them. What can you tell us, just in general, of the benefits and why OEMs have gone to viscous in Europe, and especially maybe earlier than some of the other markets?
Yeah, basically the reasons why customers in Europe use viscous drives for quite some years are fuel savings, noise reductions, and it avoids overcooling of an engine compared to a fixed driven fan. So it helps that the engine runs in the right temperature window most of the time, which also reduces wear and extends service intervals. And in general, the customers like viscous drives as they are simpler solutions compared to hydraulic fan drives in most of the cases, and typically also less expensive. And yeah, that's
Very
basically
good.
it.
So you touched on that simplicity. Oh,
Yeah.
Yeah, so you touched on that simplicity. And, this is kind of an overview of, the market technology as it is today, as well as kind of the RCV, or the fully variable drive. Now, we want to stay, these guys are giving good input on like kind of what the customers are thinking. So we definitely want to keep down that path. Neil and Ricky, I'd like to bring you in here, and maybe Neil first. Tell us a little bit about these two technologies that we're looking at, and kind of and what we're looking at essentially.
Sure. So yeah, again, as mentioned before, this semi-variable, as we call it, technology has been available in the market for a number of years. It's really the only option that OEMs have had if they want some kind of a variable speed drive and they don't want to go hydraulic. This is really the only option, or has been the only option available to them. And as you can see here from the slide, this technology, I mean, just looking at it, it looks complex. There's a lot of parts. This technology taps into the engine oil, which it can be a little concerning, I guess, especially from an engine manufacturer might be a little bit wary of that. But there's a lot of parts and pieces here. There's fittings, there's valves, there's hydraulic lines, and so there's a lot of parts. It's complex. It takes a lot of time to install, and there's just a high risk of leaks simply because of the number of connections available. And just speaking from a perspective of calling on OEMs, as we've been doing VOC work over the years to understand what customers are looking for, it's these things that they've said. They said, hey, we want something that's simpler, we want something that's self-contained, we want something that's truly variable speed. We've heard evidence and had discussions with customers where they're just they're not happy with the performance of the current technology, and it's semi-variable. It sort of does the job, and again, but it's really the only thing that's been available to them. So that's what they've had to live with. And so these are, again, some of the things that we've heard, and really is what led us into the technology that we're offering, which is the RCV 2000. And really, this is essentially, we're just piggybacking on viscous technology that we've been doing since the 80s. And so this is really nothing new for us, but it's just we're just adapting the viscous technology to a larger platform. And what you can see here with the RCV 2000 is simplicity. You basically bolt it to the engine and you plug the controller in, and you're done. That's it. It literally could take you 10 minutes to install this thing. Reliability, we've done this thing has been, we've tested and been in development for, I think, 7 years with this guy. And so we have just tremendous confidence in it. In the mining industry, durability is king. It's considered standard. If you can't run through a repower, then don't even give it to us. Don't even sell it to us. We don't want it. And so we've had to take that into consideration with this product design. So it's designed to live through at least one repower interval. Maintenance wise, very little maintenance. There's bearings that need to be re-greased occasionally, but other than that, that's it. Nothing else that you need to do. And it's also completely self-contained. So this is not plugging into the engine oil. It's not running hydraulic lines. There's no other fittings or connections. So as you can see from the slide here, there's less than a third of the parts of the existing technology. So, lower part count equals, a reduced chance of something happening or something failing. And so we've just got a fantastic product for this market.
Thanks, Neil. So, we'll bring in Ricky here, talk a little bit about, you see a lot of repowers and you talk to mines very often. and you've really gotten your hands dirty with this stuff. So, what can you tell us about some of the, maybe the more specifics of some of the things Neil was talking about with regard to the complexity of, and maybe some of the troubles that that customers have had with some of the existing technology?
Yeah, sure, Blake. And look, extending on what Neil was talking about before about the semi-variable fan drive, a couple of the big differences straight off the bat is the semi-variable fan drive is an open loop control as opposed to the RCV, which is a closed loop control. So aside from that, the semi-variable fan drive that you see on the left-hand side of the screen there, it shares engine oil with the engine. So, as the fan drive does wear, you can get some type of contamination with the engine oil. And that has been explained to me by customers who have said, look, they've had false readings when they've taken oil sample through servicing. So, that can cause some issues. Some of the other issues that customers have mentioned to me has been the solenoid control. If they have problems with the solenoid control for the semi-variable system there, it will go into a solid fan drive state and not providing any benefit at all once it's in that state. So, if you have a large fleet and they're all using that type of technology, then you are at risk of using fuel when you don't need to use fuel. So it's not as efficient as what it should be.
Ricky, along those same lines, can you kind of walk us through what we're showing there on the right side and what that means with regard to your, kind of talk about a solid state fan drive, and maybe tie it back to the various technologies of direct drive or semi-variable and what that means for the customer?
Sure. Again, going to the graph on the right-hand side, you can see where the RCV 2000 is tracking the fan speed to the speed command. So it's that closed loop control that I was talking about before. Whereas the semi-variable control is open loop, so you're not getting that tight control as shown there on that graph. But the other side of that is when it goes into that solid state, it almost becomes like a direct drive. So, the fuel savings that you're achieving by putting a fully variable fan drive to the truck is anywhere up to 7% fuel savings, as you can see there on the left. So, if you're talking about a 16V engine, which is potentially 850 litres an hour of fuel, and you can reduce that by 5 to 7%, that's a huge saving to the mine operator or even the contractors who are using these trucks. It's certainly something that's worth considering by having that tight fan control.
Perfect, thank you. So maybe Matthias, I think anything to add there with regard to direct drive versus a fully variable fan drive?
Yeah, just one example that a customer of ours gave me a couple of years ago. That's a European excavator manufacturer, and they compared direct-driven fan with a viscous-driven fan in cold ambient, and they said the fuel savings they had there were up to 12%. That was the highest number I ever heard from a customer.
Interesting. So, and then maybe Neil, any other additional stories or notes regarding kind of overcooling or what that can have, what kind of effect that can have on the vehicle?
Yeah, so we actually put a fully variable drive on a loader up at a mine near the Arctic Circle. And the reason for that was because the customer had issues with fuel dilution in cold weather, and which is basically a result of poor combustion and the engines being too cold. And so bottom line is with the installation of our fully variable fan drive, which basically again can essentially replace a direct drive, drop-in replacement, no other changes needed, which is what we did, and it solved the problem completely. The fuel dilution went from, I think it was around 15% maximum that they saw, and it went down to 1 or 2%, which was within their acceptable criteria. So that's one example of what a variable speed drive can do to you, or can be of benefit compared to a direct drive. Looking at kind of comparing to the existing technology, again, the closed loop aspect is real critical, because that really what that does is it runs the fan only what it needs to, and it's reading temperatures, it's making adjustments on the fly to run the fan exactly what is needed to for that particular condition. And the advantage.
Idle time, Neil. Sorry,
What's
Neil.
that?
Idle time. So, a truck will spend a lot of time in idle, whether or not that's just the air conditioning running because the operator wants his cab cool, or whether or not it's just sitting there waiting to be loaded. If you can reduce that idle time and get that RPM or the fan speed right down to anywhere between 70 and 100 RPM, then that's a huge bonus, as opposed to a direct
into
drive.
fuel.
Yeah, definitely.
Yep.
Definitely. So.
Yeah, and that's something that can be very easily quantified. Again, it's every mine site's different, drivers are different. Conditions are different, so it's really hard to make a generalization. But for a specific environment, you'll be able, that would be something that the mines and the operators can actually measure the benefits of that with fuel savings or road speed.
Absolutely. So, piggybacking off of that a little bit, what can you guys, Neil, Ricky, what can you guys tell us about, again, where these are used specifically, and also kind of how our customers could go about, changing their fan drive or upgrading, or, just going about looking at their application?
Yeah, sure. So I guess I can start there. So again, from the OEM perspective, really, today, they've got three options. They've got direct drive, they've got the semi-variable drive, which is sort of the de facto standard for engine-mounted variable speed drives in the mining industry, and then they've got hydraulics. So those are really the three options that the OEMs have. Again, as mentioned before, between in the 70 to 100 ton trucks, there's still a number of direct drive equipment out there. There are some options for the variable speed, the semi-variable drive, and then as you get into the the larger payload trucks, that's moves more and more towards the semi-variable drive being sort of the standard offering on the truck for a variable speed drive. So what Blake's got here on this slide is really kind of putting that semi-variable drive as the baseline again, and then looking at, okay, what are the comparisons between direct drive and the fully variable, and obviously efficiency and noise are going to be reduced with the direct drive, while durability and design flexibility are up. Just naturally, there's less parts, and very easy to change pulley diameters and things like that on the design standpoint.
Yeah, that's a good point, right? Because earlier when we were talking about fans, we were talking about if you have a more efficient fan that provides more airflow and you can reduce the speed, really where that design flexibility comes in handy is being able to change that pulley diameter, increase the size of the pulley diameter, slow the fan down, ultimately reducing noise. And that's before you even factor in variable speed, really. Now, variable speed can also help you achieve those lower speeds, right?
Yep.
As it will only speed the fan or spin the fan at the speed needed, right? So just wanted to add that a little bit.
Yeah, sure. So thank you. So then getting into the really the advanced technology being the fully variable RCV 2000 that we're offering. I mean, really it's an upgrade on really in all aspects compared to what's available now in the marketplace. Efficiency, again, with the with the closed loop control, we can achieve higher efficiencies of the overall system, and that again also reduce noise, simply because if we're running the fan only where it needs to be, it's going to be quieter. and we already talked about durability aspects from the previous slide, and then design flexibility. One of the actually, one of the true advantages is the flexibility. We can make any pulley you want, whatever diameter. If you want a 23 PK, if you want a 5 V belt, whatever diameter, and we can also design these things to length. We talked about fan weight earlier, and that being a concern for overhung load with bearings. So what we do is we design our fan drives to length so that we minimize the moment load on the internal bearings. So completely design flexible, and again, we can optimize the whole system with the fan drive and the fan to provide the best overall efficiency for that truck.
Perfect. Yeah. So just one quick note here. We have not received many questions or much in the chat. So if anyone has questions, feel free to pose them. Ricky, go ahead.
Yeah. So just extending on what Neil was saying before, look, we're looking at a lot of different applications for customers in the mining industry, to a lot of different engine platforms and a lot of different OEs. So, the fully variable fan drive, and similar to what Neil was saying, is we can make this adopt to a lot of different applications, and we're going through that right now. So we have a lot of interest out there in the mining industry, and if there are clients or customers or operators who are willing to take a look at this, this is something that we have the expertise in being able to deliver. So certainly get in contact with us, because we'd be happy to have a look at the application that you'd have in hand.
Perfect. Thanks, guys. Okay, so I do have a couple questions that Phil forwarded over to me. So this one is probably good for any of you. So can you explain, maybe Ricky, explain a little more how variable speed fan drives send more power to the wheels? So we talked a little bit about truck speed. We talked a little about efficiency with both fans and drives, and what that can mean for fuel. What does that mean for like available power and some of the other things that customers are trying to achieve with regard to maybe weight, how weight affects it, as well as just overall efficiency?
Well, I'll talk, maybe Neil can go into it a little bit as well, but I'll talk a little bit about parasitic loss. If you can reduce a lot of the parasitic load on the engine, and by fitting a fully variable fan drive, then certainly that's an area where you're going to have more available horsepower from that engine to go to other components on the truck. So, by reducing that parasitic load, by disengaging the fan when it's not needed, potentially even if it's only running an aircon because the operator wants their cab to be cool, and that's an area where you are either getting some fuel gain efficiencies or getting some horsepower gain efficiencies. So, these are some of the areas that you'll be able to translate a lot of that saving into more power, available power from the truck.
Yeah, I can add on to that, Ricky. Thank you. So basically, fan horsepower is generally going to be between 5 to 10% of the engine horsepower. So, and when you look at that on a, if you've got, 3,000 horse, well, you can have 150 to 300 horsepower taken up just by the fan when it's on, 100%. With the large engines, you're probably going to be looking at closer to that, 5% range. But still, okay, 150 horse to drive a fan, that's a lot of power. And if you can reduce that fan speed by just 30% roughly, you're going to save half the fan horsepower. And in a lot of applications, a lot of environments, the fan does not need to be 100% of the speed. And you look at areas like Canada, for example, I would doubt that the fan would ever need to be at 100%. And again, unless under extreme conditions, high ambient, whatnot. But the average fan speed is going to be 70% and probably a lot lower than that. And so you have that that fan horsepower that normally would be taken up by the engine to spin the fan is now basically freed up. And so, like Ricky said, that can be used for other components, or it can be more power for the wheel motors. And we've had customers that have expressed interest in increasing road speed. So as long as you don't have a shovel limited mine, if you can increase the road speed, you're going to get more runs, and that translates directly into profit. And so there's an advantage of having more horsepower available to wheel motors. And I mean, some of these guys are tracking down to 1/10 of a mile an hour. And if you can get 1/10 or 2/10 of a mile an hour increase in your average road speed, that's going to translate into some pretty big profits.
And at the same token, we don't want to neglect the value of weight as well, right? So we've heard from our OEM, almost all of our customers, and we know, certain major OEMs truly focus on weight, especially on like the 100-ton trucks, to where that weight saved in the truck will directly correlate to, truck speed or available payload. So yeah, definitely all good points, and that's a good question. Unless there's anything else to add there, I think we could go to another question that we received. So you guys mentioned closed loop and open loop. Could you just describe a little bit more about that, and what does that mean? What does that mean for, like, with regard to the fan, right? So how does the fan know how much? How does the fan know how much cooling it needs? How fast it needs to spin?
Yeah, I can address that. So essentially, closed loop is what we call, basically, it's a smart system. And what the closed loop fan drive is doing is it's constantly monitoring the fan speed. It's reading the fan speed, and it's checking what the controller wants for the fan speed, and then it's making adjustments to the fan to match what the controller is asking for. And so it's closing the loop. It's basically a feedback loop. And so it's constantly changing that fan speed based on what is needed, or what that controller or the engine is calling for at that specific time. The open loop system doesn't have that feedback. So all the open loop system is doing is it's taking a command from the engine, and it's saying, okay, apply this percent, or apply this frequency and to the fan drive, and then just let the fan do what it's going to do. And the problem is that the systems are not they're not, I guess, stable. And so you can apply, let's say the engine commands 50%, and it says, hey, I want 50% of the fan. The drive is going to do something internally that's going to put 50% to the fan, but the fan might be at 70, it might be at 30. It doesn't know what the fan speed is, and so it's not optimal. It's a lot of times it's actually going to be running the fan faster than what it really needs to be. The other thing that can lead to is instabilities, because in an open loop system, because you're not having that speed feedback loop to really dial in that fan speed and keep it there, these systems can oscillate in an open loop control. And so that can lead to other concerns with noise and, again, more horsepower and things like that.
Thanks, Neil. So I was just informed that there was an issue with the chat, but that has since been fixed. So if you have any questions, feel free to just throw them in the chat and we can address them. But to kind of further that conversation, Neil, maybe Ricky or Neil, or even Matthias as well. So you mentioned the controller, and the controller, giving that signal to the fan in real time. How does the controller know what fan speed that it needs, and what information are we giving to that controller in order to determine that fan speed?
Yeah, well, there's actually a couple different ways to do it. A lot of what we're seeing is the engine manufacturers can actually have a lot of influence on that by building that into their engine control strategy. So they can actually look at coolant and charge air and all the other different subsystems and say, okay, based on this temperature, here's what I want the fan to be at, 50% or 70% or whatnot. And so they can build that into their engine controls, and then they can send that signal to our controller, which will then essentially close that loop to the fan drive and the fan. That's one way to do it. The other way to do it is to build all that control into the controller. And so with our system, what we do is we basically tie into the J1939 CAN bus. We can read in the various temperatures, the status of the subsystems and whatnot, and then we can essentially program in the controller exactly what kind of fan speed mapping we want and fan control that we want. And we work with the customer on that to essentially set that fan speed mapping parameter, and then the controller will basically do everything for the controlling the fan speed independent of the engine.
Perfect. Anything to add there, Ricky?
Yeah, so just additionally to what Neil was talking about, we also have the facility to add other inputs. So if it's not a truck, if it's a different earth moving machine, then and you want some hydraulic inputs or air conditioning inputs where you want the fan to engage to reduce the core temperature of a radiator package or a oil cooling package, then we can take those inputs and put them into the controller and engage the fan to a certain percentage or a certain RPM, depending on the application. So, you know, it is flexible. We can have up to 8 different inputs, depending on what the application is. And it adds a little bit more to our complete package for this RCV 2000 fully variable drive.
Very good. Thank you, Ricky. So one other question that we got was for you to repeat kind of, or maybe go into a little bit of detail around the life expectancy for HTEC. You know, our fans have been on Komatsu applications for going on 5 years now. What are we learning from that? Neil, or maybe start with Ricky to talk through that as you brought that up. And then maybe Neil, if you have anything to add.
Yeah, sure. So look, some of the bigger issues that we've seen with the OE fan or metal fan that was on the trucks was durability problems. And those fans were getting roughly around anywhere between 18,000 and 24,000 hours on some sites, not all sites, but on some sites. And it just wasn't meeting their criteria for the scheduled engine repower intervals. So one of the things that we've been able to really help achieve a higher hourly rate is with the HTEC thing. And yeah, we've had fans that have come off at 35, 36,000 hours, and looking at the fan, you wouldn't know they'd done 36,000 hours. It's in very good condition, no obvious signs of wear or abrasion. So, you know, this has been one of the strengths of the HTEC fan, especially working in the Australian mining environment. It's performed very well, and to the point where it's now been used widely on the Komatsu repowers in Western Australia, here in Australia, and also in the Hunter Valley.
Very good point, Ricky. Unless Neil, you have anything to add on that?
Well, you know, like you said, Blake, we've had, you know, these available for, you know, the Komatsu trucks since around 2015-ish. And there's literally, I mean, hundreds and hundreds of these in the field right now. Primarily Australia, but we also have them, you know, in, you know, South America and South Africa and Chile and Canada and whatnot. But never had any issues. You know, as Ricky said, the durability aspect is very key. In fact, you know, there are mine sites in Australia that are actively converting all of their metal fans to the HTEC technology because they like it so much, and because they are we've proven to them that the durability aspect is advantageous over the the metal technology. And just looking at the design of it, it kind of makes sense, really. You've got metal fans today; they're either going to be riveted or welded, but there's going to be joints, weld joints or rivets. And anytime you have a joint, just like with the fan drive system, anytime there's a connection or an additional part or component, there's an increased risk of a failure. And so with the H-Tech fans, we've got one single blade that's H-Tech technology, that's compression molded, highly durable, that is huck bolted to a steel center disc, and there's really nothing that can go wrong. And the other aspect I guess I'll mention is that with the H-Tech technology, it's actually rated to a much faster speed as well, and that is because of the increased durability and the fact that it's lighter. And so traditionally, metal fans can run up to about 18,000 feet per minute tip speed. That's kind of the industry standard, is not to exceed. But the H-Techs can go up to 22,000 feet per minute tip speed with no issues. And so we have a faster speed rating on the fans simply because they're more durable and they can take it.
Perfect. Thanks, Neil. So we got questions rolling in a little bit. We do have a question around hybrid and electrified equipment, and I can answer that right after these questions, because we do have some follow-up questions with regard to H-Tech and plastic fans. So number one would be just, I think we can probably answer fairly quickly with regard to fan deflection. What kind of deflection are we seeing? Obviously with our nylon fans, modular too, but especially with fully molded fans, we see a lot more fan deflection. What do we see with regard to H-Tech versus metal or plastic?
Yeah, I mean, really, it's all going to be relative, depending on the speed, depending on the blade type and whatnot. But as a generality, plastics are going to be highest deflection, H-Tech is going to be in the middle, and metals are going to be the least.
Right, with metals being the most rigid, obviously. So second would be, we got a question around plastic and H-Tech in sand erosion environments, and then when you compare that to metal. And I know this is highly dependent on how the application is laid out, and specifically with regard to the application. But what can you guys tell us about kind of those erosive environments?
Yeah, it's kind of the same as the deflection. So the nylon is going to wear the most. The H-Tech material is going to wear the second least, and then the metals are going to be the most able to withstand erosion from
what can you say about What can you say about the wear patterns of H-Tech? You mentioned a little bit of wear, but I know we've also, that thermoset composite material also lends itself well to not cracking and propagating and things like that, where you might get some contact with a rock or something like that on a metal fan, and you'll see, you could potentially shed the whole blade, and then the whole fan's done. And likewise with a nylon fan, but we don't necessarily see that with H-Tech, do we?
No, regarding like rock impingement, the H-Tech does very well. It's obviously not as strong as metal. A rock will impact or affect an H-Tech fan obviously more than it will a metal. However, what we have found is that the blades are resilient, and so it can withstand rock attacks and rock impingement. And in fact, even we've done durability testing with fans where we've had chunks taken out of the blades on purpose with rocks and continued to run the fan through durability testing, and the fans continue to perform, and they don't fail. And what I mean by that is generally with either plastic or metal, even when a crack starts, it's going to propagate, and that's going to eventually lead to a blade failure. With the H-Tech material and the composite structure, what we see is a crack will start to propagate but then stop because of the lattice structure of the thermoset composite, and so it's a very interesting material from a crack propagation perspective.
Perfect. Thanks, guys. The questions have slowed a little bit. We've gotten to most of them. and I'll take the electric question. So that's been kind of a focus on my end. And the question was, can Horton offer electric fan drives for hybrid and electrified mining machines? And the answer is currently no, but we are working on electrification quite actively, like many of our customers are. So first off, I know like at Comvec here a week or two ago, which is the SAE commercial vehicle off-highway and truck convention every year, there was a lot of talk about electrification this year, and CNH was kind of the main presenter there and talked really in depth about how electrification is really taking hold in the on-road trucking markets, and we'll start to see that really transition more to the off-highway markets. Obviously, hybridization has been around in mining for 10 to 15 years. You see it both with like Cat and Komatsu. The major players have hybrid machines. So the answer is if Horton can offer, not currently, but we are focused on high voltage and then it will be 48 volt. We'll be focused on both 48 volt and hybrid or high voltage opportunities. However, as I'm sure most people are aware, the motors for very high, the motors get to be quite expensive, especially when going back to like what Neil was saying, where we're spinning fans 150 to 200 horsepower. The demand hasn't quite been there yet to stomach that application. It seems to be simpler, more cost effective to continue with the engine mounted fan drive, keep it simple and just hang it off the engine. But definitely see the need going forward with regard to electric fans and electric fan assemblies. Does anyone have anything to add there? All right, I think we can conclude this mining webinar. So we appreciate everyone joining us. Ricky, we appreciate you coming to this in the middle of the night. And Matthias, I think it's time for you to maybe grab a beer in Germany. So thanks for everybody. Thanks everybody coming. Any final words from you guys?
Thanks for joining us.
Yeah.
Yep.
Thanks for everyone for joining.
Thanks, guys.
Yep. If you have any additional questions, feel free to reach out. We have plenty of more content out on our website, so hortonww.com/mining. Find us on YouTube. We have RCV 2000 related information where you can actually watch video with regard to how the product works, its applications, as well as HTech, and these other and more technologies as well. So again, hortonww.com/mining, and thank you for joining us, everybody. Take care.
Okay, goodbye.